Question 2. A rare substance has a density of 5.6 times 10 to the power 3 kilograms per cubic meter. What is the equivalent density of the substance in the following units? This problem tests how we can convert across units using prefix values, particularly for compound quantities. So let us begin by recalling what we already know. We should know that when converting compound units, which for example is the ratio of 2 units, we treat the numerator and denominator separately before recombining them. We know that prefixes such as kilo, milli, micro, and nano simply represent powers of 10, which scale the numerical value. Another important idea is that volume units change by cubing the length conversion, since volume depends on 3 dimensions. Now let us work through the conversions. We are given that the density is 5.6 multiplied by 10 to the power 3 kilograms per cubic meter. First, for option A, we convert the density into micrograms per cubic decimeter. 1 kilogram is equal to 10 to the power 9 micrograms. We know this because it takes 10 to the power 6 micrograms to make a gram, and then another 10 to the power 3 to go from gram to kilogram, giving 10 to the power 9. Also, 1 cubic meter is equal to 10 to the power 3 cubic decimeters. This is because 1 meter is 10 decimeters, and when cubed, this gives 10 to the power 3. Substituting these conversions into the expression gives 5.6 multiplied by 10 to the power 3 multiplied by 10 to the power 9 divided by 10 to the power 3. This simplifies to 5.6 multiplied by 10 to the power 9 micrograms per cubic decimeter. Hence, option A is correct, since the obtained value matches exactly. Next, for option B, we convert the density into grams per cubic centimeter. 1 kilogram equals 10 to the power 3 grams. 1 cubic meter equals 10 to the power 6 cubic centimeters, because 1 meter is 100 centimeters, and 100 cubed is 10 to the power 6. Substituting these values gives 5.6 multiplied by 10 to the power 3 multiplied by 10 to the power 3 divided by 10 to the power 6. Simplifying this gives 5.6 grams per cubic centimeter. This option is not correct, since it does not match the given value. Now, for option C, we convert the density into nanograms per cubic decimeter. 1 kilogram equals 10 to the power 12 nanograms. Again, 1 cubic meter equals 10 to the power 3 cubic decimeters. Substituting these conversions gives 5.6 multiplied by 10 to the power 3 multiplied by 10 to the power 12 divided by 10 to the power 3. This simplifies to 5.6 multiplied by 10 to the power 12 nanograms per cubic decimeter. Again, this does not match the required value, so the option is incorrect. Finally, we convert the density into kilograms per cubic decimeter. We only need to convert the denominator here. 1 cubic meter equals 10 to the power 3 cubic decimeters. Substituting this into the expression gives 5.6 multiplied by 10 to the power 3 divided by 10 to the power 3. This simplifies to 5.6 kilograms per cubic decimeter. Looking at the options given, only option A is correct, since it matches the value in the required unit. We now have our final answer. What did we do? We started with the density in kilograms per cubic meter. Then for each target unit, we converted the mass unit and the volume unit separately, using the appropriate powers of 10. After substituting these conversions, we simplified the powers of 10 to obtain the final values. A quick summary. Ratios with different prefixes in numerator and denominator must be converted separately before simplifying. Correct prefix handling depends on knowing each prefix's exact power of 10